Now we're going to talk about how do you solve quadratic equations using the square root property. So you cannot always use the square root property. You can only use the square root property when you have a quadratic equation and there's only one variable present. So for example, you may end up with something that looks like this: x squared equal to k, where k is just some number. You have a quadratic equation because it has an equal sign, there's one variable, and the highest exponent on that variable is 2. So you have a quadratic equation, but notice there's only one variable present in the equation. If that's the case, then you can solve for that variable by isolating the variable, getting it on the side by itself. So I could get x by itself by getting rid of this square. How do you get rid of a square? Well, you have to square root to get rid of a square. And whatever you do to one side, you have to do to the other side. So I want to take the square root of the x squared because that'll make that square go away. And I also want to take the square root of the right side. And whenever you take the square root, you have to take the positive and negative square root. But on the left side, that plus or minus square root cancels with that square, and you're left with just x. And on the right side, you're left with positive and negative square root of k. So that's actually two different answers. That's x equal to the square root of k, and that's x equal to negative the square root of k. And you may also see that written in a solution set as negative square root of k, square root of k. Let's look at some examples where we can actually use the square root property to solve a quadratic equation. Example 1, we want to solve x squared equal to 64. This is a quadratic equation. There's an equal sign. There's one variable. The highest exponent on that variable is 2. So you have a quadratic equation. Now, since there's only one variable present, then you can use the square root property. So isolate the x. Isolate the x by getting rid of the square, and you get rid of the square by taking the square root of both sides. And whenever you take the square root of both sides, you have to take the plus or minus square root. So this square root and square cancel, and you're left with plus or minus the square root of 64, and the square root of 64 is 8. And so why do you have to take the plus or minus? Because think about this. 8 times 8 is 64, but also negative 8 times negative 8 is also positive 64. So because you can take a negative number and square it and get that same positive answer, and that same positive number and square it and get a positive answer, then you have to consider both the plus and minus, or positive and negative, solution when you take the square root. Example 2, we want to solve 2y squared plus 36 equals 0. So again, this is a quadratic equation. There's an equal sign, there's one variable, which is y, and the highest exponent on that variable is 2. There's also only one variable present. There's only one y in this equation. So anytime there's only one variable present, then you can isolate that variable. So what I mean by one variable present is, if it would have looked like this, 2y squared plus y plus 36 equals 0. Even though there's only one variable y, there isn't only one variable present. You got a y squared and a y, and now you cannot isolate the y with it in that format. So we want to isolate y, so we need to first subtract 36 from both sides, because isolate means you want to get it on the side by itself. You get 2y squared equal negative 36. Then you want to get rid of the 2, so divide both sides by 2. That's a negative. So you get y squared equal negative 18. And now you can get rid of the square by taking the square root of both sides. And remember, when you take the square root, you have to take the positive and negative square root. So you get y is equal to plus or minus the square root of negative 18. Remember, anytime you have the square root of a negative number, you're dealing with an imaginary number. So you pull that negative from underneath the square root and make it an I. So this becomes y equal plus or minus I square root to 18. And anytime you're dealing with the square root, you want to make sure that it's completely simplified. So can 18 be written as the product of a perfect square? So what are your perfect squares? 1, 4, 9, 16, and so forth. Can you rewrite 18 as the product of one of these numbers? Yes, you can. It's 9 times 2. So you get y equal plus or minus I square root of 9. I'm going to go ahead and break it up. Times the square root of 2. And we know the square root of 9 is 3. So we replace the square root of 9 with 3. And we get y is equal to plus or minus 3I square roots of 2. And so that will be your final answer. Y equal to plus or minus 3I square roots of 2. That's two separate answers. That's y equal to 3I square roots of 2. And that's also y equal to negative 3I square root of 2. So remember that when you write it like this, it looks like one answer, but it's actually two different answers. So you got a positive and a negative of that answer. For example 3, we're going to solve w plus 3 squared equal to 8. You want to check to make sure this is a quadratic equation and where you can actually use the square root property. So there's an equal sign, there's one variable, the highest exponent is 2. And there's only one variable present. So that one variable is only written one time. And if that's the case, then you can isolate the variable. So the first thing we got to do is we have to get rid of the square first. So we're going to take the square root of both sides. And remember, when you take the square root, you have to take the positive and negative square root. So the square root and the square cancel over here, leaves you with w plus 3. And you get plus or minus square root of 8 on the right side. And then get rid of the 3 by subtracting 3 from both sides. So you get w equal negative 3 plus or minus the square root of 8. And then you remember you always have to simplify the radical. So you want to check to see if the number underneath the square root can be written as the product of a perfect square. What are your perfect squares? 1, 4, 9. So the only one that's less than 8 is 4. Can it be written as a product of 4? Yes, it's 4 times 2. So I'm going to break it up. That's the square root of 4 times the square root of 2. The square root of 4 is 2. So this ends up being negative 3 plus or minus 2 square roots of 2. And so that would be your final answer. It's your turn. Now you pause the video for a moment and you work this one. See if you can work it out and see what you get, and then come back and see if you got it right. Okay, so this is a quadratic equation. There's an equal sign. There's one variable. The highest exponent variable is 2. That variable is only present once, so you can solve this by using the square root property. So you want to isolate the variable u. So the first thing you have to do is get rid of the 64. So since that's a positive 64, you subtract 64 from both sides, and you get 4u squared equal to negative 64. Then you have to get rid of the 4. So since that's 4 times u squared, you have to do the opposite of multiplication, which is division. So you get u squared equal negative 16. Now get rid of the square on the u by taking the square root of both sides. And remember, whenever you take the square root, you have to take the positive and negative square root. So the square and the square root cancel on the left. That's u, and you get plus or minus the square root of negative 16. Whenever you have the square root of a negative number, remember that's an imaginary number. So you can pull that negative from underneath the square root and make it an I. And then we know the square root of 16 is 4, so we can change the square root of 16 to 4, and you get that your answer is plus or minus 4i. So again, remember that's two answers. That's u equal to 4i and u equal to negative 4i. But you can write it like this, but just know that's two answers. Alrighty. And so this is how you solve quadratic equations using the square root property. Remember, if you have any questions, put them in the comments below. Also, if you want to continue to get more videos like this, make sure you hit the subscribe button. So thanks for tuning in, and you can go on to the next video, which is solving quadratic equations using completing the square.